All right, we're recording.
Okay,
Okay, so hello, this is our group discussion oops, for homework one. My name is Nicholas,
I'm done.
And I'm Zachary.
and we're gonna start with problem one, or problem 02.055, which I will be going over. So I'm gonna start screen sharing. Okay, so you guys are able to see this.
Yeah.
Yeah.
All right. So for this problem, in my pre-attempt, I said we need to make some assumptions. So, the pulley at point C and all the cables are assumed to have negligible mass, so we can actually solve the problem. And then always, oh, sorry, this is the wrong problem. Okay, but similar
Yeah, I
idea.
was confused for a moment.
Oops. Okay, so I'll actually be doing 02.099.009. So for this one, it's just basic trigonometry and vector decomposition. So we can do this by first establishing a coordinate system. So I have positive x and positive y going like this. And then afterwards, we're also given several quantities. Uh, so we want um, the x component of the resultant force, total force, to equal 6.40 kilonewtons. And we're also given that the force of AB, the force of tension on AB is 3.0 kilonewtons. Um, so based on that information, um, we were able to solve because we want this car to have a net force or net Y component of 0 newtons as well. So that means we can set up the sum of forces. Um, let's see if we can do like sum of forces in the Y direction to be 0. So that means the tension of FAB and FAC, their Y components has to equal 0. And somewhere I think we're given that uh wait. Oh yeah, we're given the total magnitude of like AB, so we can use that we can use vector decomposition to find 3.0 times sine of 30 equals 1.5 kilonewtons. And then since FAC acts in the opposite direction, it would have negative 1.5 kilonewtons. And so the problem wants the sum of forces in the x direction to be 6.4 kilonewtons. So then we can establish that as an equilibrium as well. And then FABX plus FACX equals 6.4 kilonewtons. And then we can use that to, you know, to find that FAC equals 3.802 kilonewtons. And yeah, and then we get the magnitude of FAC, which is the problem asked for, and
Hmm.
also the angle alpha. So, do you have any questions or anything?
No.
No? Okay.
No.
All right, we'll move on to the next problem then.
Okay. Now let me pull up the second question. Now, where did I put it? Okay, got it. Can you see?
Yep.
I didn't have the thing, but we have problem two where it has a suspended pulley, which is the dot right here in the middle. Um, and then we have tension in from C, which is the dot, to A, which to the left in black, and then from C to B, which is in black tension. And then we also have TCD, which is the blue one to the left, which is pulling at constant speed, which means that acceleration equal to 0. And then we have the weight of the body, which is pull straight down in blue. Since the system is in constant velocity, fx was equal to 0 since a is equal to 0. And then we got t, which is the tension in both of CA and CB, which is t cosine of alpha. Alpha is the angle to the normal from the black line. And then beta is the angle from the other one. I didn't label it, but yeah. We
Hmm.
also have Fy equal to 0, which is net force in y direction equal to 0. Uh, from there, I derive a uh, formula for TCD from the net force in x. After that, I derived the in y. I derived the weight to be I moved the weight to the left side since it's equal to 0, and I replaced TCD into the equation of um the net force in y, and so I got T uh parenthesis sine alpha plus sine beta parenthesis, and then minus T parenthesis of cosine alpha minus cosine beta, and tan of alpha because cosine of uh alpha right here match with the sine of alpha right here give us tan. And then I uh calculated using my calculator. I just moved the entire thing since I group up the t. So I moved the entire thing over and then just divide the weight by whatever this part is, and then I got T. And then afterwards, TCD was just plugging in the T value that we got. Um, and yeah, that's about it. Any questions?
Mm. So you just ended up like because it just has all the variables, right? You just ended up like plugging it in to your calculator.
Yeah, I usually do my problem that way. I usually just do everything in algebra and then I plug it in at the end.
Mm.
Interesting.
Yeah,
Hmm.
very interesting.
Hmm.
It's less usually it's less like calculation error that way.
Yeah, that's true.
Mm-hmm.
You don't have
I
to
should do that.
round the number.
Yeah, I kind of wrote down a lot of stuff. It looks a lot more messy, but yeah, it's probably better.
Yeah.
Any other question?
No.
Not really.
All right, shall we move on to the third one?
Yeah.
Yep.
So I um I'm gonna share on my screen real quick. Can I see that?
Yeah.
Okay,
Yes.
so um I'm gonna go ahead with number 4, which is this diagram here shows describes the system in like a 3D version of a 3D version of a free body diagram of the whole system. And so we have the original force being 303 pounds force in this direction. And so we have the main equation that we're going to use throughout this whole problem, which is f of x, f of whichever direction equals the magnitude of the force times cosine of the angle in the direction that you're focused on. So first we need to find the force. Let's start with like the force caused in the x direction, the the, the x component of the force. So in order to do that, you have to first find the take the magnitude of the force, plug in the angle of the y value, And so that will let you have this magnitude of force in the XZ plane. And then, so that's your F of H force. And so you would multiply that by another cosine so that this force that you get, the force in this area, it would be, let's say, like kind of shifted over to get that X component you want. And so basically, you can simplify it to the magnitude of the force, sine of the Y angle, cosine of the X angle. Once you plug in all these values, you get the force in the X direction. And so you basically repeat this process for the Fy and F of Z. And so the next part of this problem is to find the angle of from each axis to the force itself. So it's not the force, it's not the angle between the axis and the component of the force. That's the mistake I did before, and that took me like 20 attempts before I realized that it was completely wrong. What you really have to do
Yeah.
is use the same equation that you used in the previous problem, and you solve for the angle itself. So basically, you rearrange this equation so that you isolate the theta, and so that results in theta equals cosine of the component of the force over the magnitude of the force. And so when you plug the numbers in for, let's say, theta x, you get theta x equals cosine of minus 79.4 over 303. And that's how you get the theta x. And you repeat the same process for the theta y and theta z. And that's all there is to this problem. Any questions?
Um, I think for
Wait,
theta y, you didn't need to calculate it since it's already given in the question.
Okay, so yes, technically it's already given for the y direction. So it's kind of trivial, but the whole point, the whole concept of the question is to find the angle between the axis and the force itself, not like the projection of this force onto whatever plane you need.
Hmm.
Yeah. So like 40, you could say it's given, and it you might try and put that in as your theta x, but it's this angle is not the same as this angle.
mm,
Yeah.
Yeah, I think for next time, when I think for this problem itself, it's make it easier for me to visualize when I draw the free body, the three axis on
Mm-hmm.
top of point B instead.
Oh yeah.
Yeah,
Eh, I
it's
just like to be more accurate.
yeah.
yeah, I did end up doing that too. But then it made me think like AB made a like what is it, like 90 plus 40. So
Me
it made me
too.
think it was 130, which like is definitely wrong. But
Yeah.
it kind of looks like that, if you
Hmm.
guys
Yeah.
know what I mean.
Yeah. That's exactly why I took like 20 attempts.
Yeah. Wait, so isn't it isn't theta x just like the angle to like the
From the force itself to the
Okay.
x-axis.
So if you look at the graph,
mm,
we have this straight line, right?
mm,
And the whole point of this question is to, let's say this line is our plane, right? And like it's like we're kind of rotating it the whole system in a way such that this is our x, um, right hand rule. Let's go for this is y and this is z. Trying to find the angle between our axes and the plane. Yeah.
mm. So the plane
Uh,
that AB lies on.
Yeah, basic. It's kind of like that.
Yeah.
Or like you could say the line, but like yeah, same thing.
Hmm. Okay.
Yeah. Any other questions?
Not really.
Yeah.
All right. I guess that concludes this video recording.
Yep. Good discussion.
Yeah, good discussion.